Have you ever pondered about the significance and implications of data manipulation? Have you ever thought about how critical it is to be adept at reading and interpreting data? Data manipulation is a cornerstone of data analysis and business intelligence, enabling us to convert raw data into meaningful information. It aids in the creation of actionable insights that can drive decision-making in a variety of fields, from business to healthcare, and everything in between. Today, we're embarking on an exploration into this pivotal aspect of data science, data manipulation, and we're going to do so using one of the most potent tools in our arsenal, Pandas. It's not just any tool. Pandas is an open-source software library providing high-performance, easy-to-use data structures and analysis tools for Python. In this video, you're not just going to learn about abstract concepts. We'll guide you through hands-on examples and exercises demonstrating how to use Pandas to read and write data, clean, messy data sets, and perform complex data manipulations. By the end of this video, you'll have a solid understanding of data manipulation and you'll be able to utilize the power of Pandas to its fullest. So get ready to step into the world of data manipulation with us. Pandas can be considered the ultimate tool in a data scientist's toolbox. Much like a Swiss Army knife, this versatile Python library provides high-performance, easy-to-use data structures and data analysis tools. With its flexible and efficient data frame object for data manipulation, Pandas allows for seamless data import and export, intuitive data wrangling, quick and efficient data cleaning, and simplified data visualization. In addition, it has powerful and flexible grouping functionalities to perform split-apply combine operations on datasets, and it supports time series functionality. Its comprehensive features make it a staple for data scientists who require a powerful and streamlined tool for comprehensive data manipulation and analysis. Starting off, one of the most frequent tasks in data analysis involves gathering and reading data from a variety of sources. These sources may include a CSV file, an Excel spreadsheet, or SQL database. With the powerful Python library Pandas, this task becomes a breeze, requiring just a few lines of code. Let's look at how this can be done. If you're working with a CSV file, the read_CSV function comes in handy. All you need to do is provide the file path as an argument. For instance, if you have a CSV file named data_CSV in your current directory, you simply write df =ptd.read_CSV data_CSV. Your data is seamlessly loaded into a Pandas data frame, ready for manipulation and analysis. Similarly, if your data is contained within an Excel spreadsheet, the read_Excel function is your ticket. The usage is identical to the read_CSV function. Just provide the file path as an argument, like so, df =pd read excel data.clsx. If, however, you are dealing with data from a SQL database, the read_SQL function is designed for just that. This function, unlike the previous two, requires two arguments, a SQL query and a connection object to the database. For example, if you wanted to load a table named customers from your SQL database, you would write df =pd.read_SQL select asterisk from customers connection. This would load the entire customers table into your data frame. In a real-world scenario, this function would be incredibly useful in a situation where you need to analyze customer data stored in a company's SQL database. With Pandas, reading data from different sources becomes a walk in the park. The examples mentioned here are just the tip of the iceberg. There are plenty of other functions and use cases which you can explore to further enhance your data analysis skills. Now, once you have read the data, you'll have it in a Pandas data frame. Pandas data frame is a two-dimensional, size-mutable, potentially heterogeneous tabular data structure with labeled axes, rows and columns. It's akin to a table in a relational database, a dictionary of series objects, or even just a spreadsheet on your computer. Data frames are extremely versatile and allow for a wide range of data manipulation techniques. For instance, you can filter data based on certain conditions. Suppose you have a data frame containing information about a group of people including age, and you want to filter out only those who are over 25. You can accomplish this with the following command, df age and gt25. You could also group data based on certain fields. If you have sales data and you want to find out the total sales by each salesperson, you could use the groupie function, like so, df groupie salesperson sum. Furthermore, Merging multiple data frames is another highly useful feature. Assume you have two data frames, one containing customer information and another containing order details. To create a single data frame that allows you to analyze customer behavior along with order details, you can use the merge command, like pd.merge df1 df2 on =customer_IDD. The power of Pandas lies in these abilities to flexibly manipulate data, catering to a plethora of data science and analytics use cases. Whether you're cleansing data, analyzing it, or preparing it for machine learning models, Pandas data frames are a vital tool in the data science toolkit. Now imagine you've just completed an extensive data analysis task and your goal is to save all these hard-earned results. But how do you do that? Well, with Pandas, a software library for Python, you can effortlessly write your data frame back to a CSV, Excel, or SQL database. Let's delve deeper into this. To write data to a CSV file, you use the _CSV function. For instance, if you want to save a data frame called df to a CSV file named data_csv, you would use the command df to csv data_csv. It's as simple as that. CSV files are widely used for their simplicity and readability, making them ideal for quick data exports and manipulation. If you're dealing with more complex data structures, Excel could be your go-to. The _Excel function is used here. For example, df.to_excel data.clsx will write the data frame df into an Excel file called data.clx. Excel files are excellent for storing large data sets and for executing advanced data analysis tasks. For databases, Pandas can write data frames directly to SQL databases using the _SQL function. Suppose you have a database named database and you want to write your data frame df to a table named table. The command would be df.toSQL table database. SQL databases are universally recognized and allow for robust data management and analysis. Pandas streamlines the process of saving your results, whatever the destination may be, allowing you to focus on the more creative and challenging aspects of data analysis. Remember, the right data storage method will depend on your specific needs and use case. In essence, data manipulation with Pandas consists of 4 comprehensive steps: reading data where we import data from different sources into a data frame, manipulating data where we clean, transform, and enrich our data, analyzing data where we discover patterns, relationships, or anomalies to draw meaningful insights, and finally, writing data where we send the manipulated data back different sources or export it in different formats like CSV, Excel, or SQL. To summarize, we've dived deep into the world of Pandas, a potent tool for data manipulation and interpretation. Our exploration took us through the process of reading data from a plethora of sources into a data frame, then meticulously manipulating this data within a data frame, and in the end, writing the results back to a variety of sources. The mastery of these skills enables you to convert raw, unrefined data into significant insights, a much sought-after competency in our increasingly data-driven era. Therefore, with this knowledge in your arsenal, venture out and delve deeper into the oceans of data with Pandas. As a quick of our video, we've started with understanding what Pandas is and its importance in data manipulation, before moving on to learning about the 4 core steps involved in the process. After that, we've seen practical examples of how these steps work and how they can be used to extract meaningful insights from raw data. We've also discussed the importance of these skills in today's world. So, equipped with this new knowledge, we encourage you to put your learnings to practice and explore the fascinating world of data with Pandas.